Okay, so this is the first thing. I'm adding that much water. I'm trying to use my camera so you can actually see the meniscus. I'm adding that much water to this can. Okay, so you can see, I think I called this the apparatus or something like that in the lab protocol, but I have a watch glass and I have a paper clip and I have a cheese puff on it, and I put it in that position because I'm gonna burn it, and as you know, if you burn something, it's good if you light something from below, the fire will spread from up above. So it's pretty much in this position to get maximum burn. Okay, so here's the full setup. I have a thermometer, and the thermometer is measuring the temperature of the water, and I'll zoom in on that so you can see that temperature there. This is too hard to read. Hopefully it's visible. Okay, so try to get that temperature down. Feel free to pause the video to get the temperature. Okay, you need that temperature. That's the initial temperature of the water. And then if I zoom out a little bit, you can see the full apparatus. So I put that cheese puff and I tried to get it as close to that can as possible. So as it's combusting, as we're acting all of the molecules that essentially give that cheese puff energy, all that energy is meant to transfer into the can. So let's see how this goes. Here we go. Try to light my puff on fire. And what I want to do with the temperature, this is important as I'm lighting this, I want to try to get the maximum temperature change. Really start to go. See, there we go. Okay, look at that baby. Whew, smells smells wonderful in here. Okay, so you can kind of go see. I want to make sure that this is completely gonna burn. You can see that I'm trying to get all that energy into the can. I want to make sure that I burn that cheese puff as much as possible. And let's take a look at that temperature. Clearly it's going to be rising. I'm trying to get the temperature of just the water, not of the can, because they actually have different specific heats, right? And I'm trying to just get that water temperature. And look at this. Oh my goodness, guys. It is quite a fire. Look at that cheese puff, my goodness. All right, let's go back to our temperature here, so you guys can try to get that maximum temperature reach. It is, oh wow. I wish you could be here as I'm nearly burning my phone trying to get this video recorded here. Look at that. Look at the energy of that cheese puff, amazing. And you can kind of see that sadly I'm losing some of that energy. It's not going all into the can, so this is not a very efficient calorimetry experiment, but we do it. Okay. Temperature continuing to increase. I think you can see that pretty well. And the cheese puff is now out. Okay, let's get that temperature. It's starting to go down, you can see. So hopefully you get that maximum. Okay, so here's our charged puff. You can see the new mass after burning. And I'm gonna zoom in a little bit. You can just, first of all, like it looks just like charcoal, right? And it's because it basically is charcoal. All you have is sort of a tangled mess of long carbon chains, and a lot of the hydrocarbons have been burned off, producing carbon dioxide and water in the presence of oxygen in the air. So we're kind of left with like a charred log, right? We've seen this before in campfires as well. It looks pretty similar. And then I wanted to show you this. This is a nice little nugget here. You see a little bit of dripping fat, right? So we didn't actually combust all the fat. As the combustion occurred, some of the fat essentially melted and then just dripped right onto our watch glass there. All right, and then you can get that. I think you're good to go to start some calculations. I wanted to show you this one last thing. If you look at the can, it's actually got a fair amount of soot that's deposited on it. And that's from what's called incomplete combustion, in that we couldn't quite get the right ratio of oxygen to the hydrocarbon to combust it completely. So a little bit of inefficiency there. So and I just mentioned this because if you've ever seen these soot in your tailpipe or like on the side of the road or anything like that, that's what's happening. The combustion is incomplete, so we're essentially putting like some particulate carbon waste into the atmosphere. And it's kind of like the vapor equivalent, or the particle equivalent of that charred up Cheeto that you just saw.